So in this one, first let us try to define a rigid body better. What do you mean by a rigid body? What do you mean by a rigid body? Circular motion and any applications, they will be useful here better, like angular displacement, angular velocity, okay, angular acceleration, that all are
Yes.
very important. And how do you convert the angles also? Okay, Okasari, please try to revise that all formulas related to the circular motion introduction part. Okay, na?
Okay. Yes.
Okay. So what exactly is a rigid body? What do you mean rigid body, beta? A fixed, a constant body in which the distance between any two particles will always remain same. Like say, for example, a stone. If it is a very rigid stone, the distance between any two molecules will always be remaining at rest unless and until you apply an external force to break them, isn't it? Like say, for example, of your solid sphere. Even in the solid sphere, the distance between any two molecules will always remain to be your same partition. So a rigid body, a rigid body, a rigid body is said to be in pure rotation, is said to be in pure rotation if every particle of the body moves in a circle and the center of mass are moves in the circle and the centers of all circles and the centers of your all circles lies on a straight line, is called axis of rotation. Is called what? Axis of
Axis of
rotation.
rotation.
So what do you mean rigid body? A rigid body is said to be in pure rotation. Like example, fan. So if you take your fan, the axis of your fan is always at this given condition.
Yes, sir. It is
Isn't
in
it?
pure because every particle is moving.
Yeah. So each and every point right now, if I'm taking this one right now, this one, and even this one, this point right now. Okay. So each and every point of this one will always remain at your same position. Like if there are two particles here, one particle P, this one is Q, and this one is R. The distance from this axis of rotation. Just a minute,
Yes.
okay. Is it audible, beta?
Yes, sir. Audible, sir.
A rigid body is said to be in pure rotation if every particle of the body moves in a circle. Like if I take one particle of this blade of the fan at a distance of R, at a point R, then another is at Q, another is at R. Is the distance of this point P from this axis is always constant now, beta?
Yes, sir. It is.
You switch on the fan, this particle will every time will be moving in the same circle without changing the, what do you call that one, radius, isn't
Yes,
it?
sir.
So every
Yes.
particle of the body moves in a circle and the center of all the particles lies along the straight line. This is called as of your axis of rotation. This is called as of what? Axis of your rotation. Clear?
Yes, sir. It is.
Even if I take something rigid body like this, like say for example, if I'm taking a rigid body like this right now, ఇది ఒక rigid body అనుకో, ఇక్కడ ఫిక్స్ అయి ఉంది ఇది, here it is right now fixed. Okay, this is your fixed. Now you start rotating it అంటే కొంతసేపు అయిన తర్వాత, like say for example, this body has been come to this position. Okay, that
Yes,
means
sir.
initially when the particles were somewhere here right now for the given condition, all the particles which were been on the axis of this one right now for the given condition, like say like this, e particle ki E, this was your axis, E rigid body initial. This one is,
Yes.
say, for example, 1 point. This one was 1 point. And this one was 1 point. Okay. So this one is, say, for example, A. This one is your B, and this one is C. When the particle goes from here to here, the line will come here right now. This will be your C. This will be your B, and this will be your A. And this will be,
Yes.
say, A dash. This is B dash. This is your C dash. So C has been traveled a distance from here to here. This is your C dash, C to C dash. B has been gone from B to B dash. A has been gone from your A to A dash. But for
Yes.
both of them, the axis is fixed,
Yes, sir, it is.
isn't it? So every time this angle is always constant. If here it is 30 degrees, this is also 30 degrees. This is also 30 degrees, isn't it? If A
Yes,
is
sir.
being an angle 30 degrees, then what is angle between B and B dash? Obviously, same angle, not
30
30
degrees.
degrees.
Yes, sir.
C and C
C
dash
and
will
C
also
dash
be the
also
same.
same, sir.
But
Yes, sir,
only
30
thing is
degrees.
difference is there what? Distance from the axis, isn't it? If this
Yes,
distance
sir.
is your RA, this distance is your RB, this distance is your RC. So velocity of particle A is equals to your V is equals to your RA into your omega, because angular velocity for both of them will be same. Velocity of the B will be equal to your RB into your omega. Velocity of C is equals to your RC into your omega. Now, whose velocity, whose radius is more beta? RC is greater than of your RB, and RB is greater than of your RA. That means I
Yes,
can
sir.
say that velocity of C will be greater than velocity of your B, and velocity of the B will be greater than of your velocity of your A. But for all of the bodies, angular velocity will always remain for me the same part of relation. Okay, now
Yes, sir.
is that point clear?
Yes, sir.
Isn't it? And in this one, all the formulas which I told you for related to your what you call the angular velocities, that all are been applicable here in the given condition, beta. Okay, na?
Yes.
Okay. What are the particle? What are the forces responsible for a particle to move in a circle, beta? Okademo centripetal force. Another one is tangential acceleration. So what are the
Yes, sir.
formulas? You just revise me. Centripetal force or centripetal acceleration is equals to V square by R. Tangential acceleration AT is equals to your dV by your dt, or AT
DT.
is equals to your V is equals to your R omega కాబట్టి this will become for me how much for me? D omega by dt is nothing but of your R into your alpha. అవునా కదా? So AT is equals
Yes,
to
sir.
your R into your alpha. Resultant of this one is A is equals to under root of your AC square plus of your AT square. So this all formulas are applicable in the circular motion part of relation. Okay, na?
Okay.
Let us try to come for a topic, torque. We'll talk about in this one, torque or moment of force. Torque or moment of your force. Very important topic, but torque and your moment of your force. This is also called as of your turning effect. You will be opening and closing the taps, na beta. That is based upon this torque part only.
Okay.
Turning effect of force. Turning effect of your force. You just imagine how you open and close your tap right now. See, you will be using your two fingers. Say like this is the tap handle. You exert the force with one hand in this one and another hand with another finger in this direction. You just imagine you will be using your right hand to open your tap. With the one thumb, you will be exerting the force in one direction, and with the other
Yes, sir.
finger, you will be exerting the force in the other direction. So you will be
Yes, sir.
acting only one force on this body, but in the opposite
Opposite
direction.
direction.
Is your turning effect of your force part of relation. Okay, na? I'll just
Yes, sir.
try to revise you beta. మనము kinematics la distance ni s తో represent చేస్తున్నాము, and rotation motion ni we'll be representing in terms of your theta, and the relation between
Okay.
them is nothing but s is equals to r into your theta. అవునా కదా? In
Yes,
kinematics
sir.
we represented by velocity, in rotational mechanics we represented by omega. Relation between them is v is equals to your r into your omega. Okay, and we
Yes, sir.
also take the tangential acceleration there, whereas in the circular motion we take it as of your alpha, and the relation between them is nothing but of your tangential acceleration is equals to r into your alpha. The same way, in the Newton's laws of motion we represented by force, in circular motion we represented by your torque beta, and here torque is equals to your r bar cross of your f bar, like a cross product condition. Okay, and next one
Yes,
is
sir.
their mass. In the Newton's laws of motion, we represent the mass by your m. In the rotational mechanics, the mass is represented by your I, where I is known as moment of inertia. And this I is equals to your m into your r square. I is known as what? Moment of inertia.
Inertia.
And whatever is the role played by the mass in the Newton's laws of motion, the same role is played here by your moment of inertia,
Inertia.
that is
Yes.
capital I. Whatever is the
Yes.
role played by the force in Newton's laws of motion, the same role is being played by the torque in the rotational mechanics part of relation. So these are the some of the formulas you should always be in your hand, and these are your linear motion equations. These are your linear motion equations, and this one is of your circular motion.
Yes.
These
Sir.
are your circular motion relations or rotational mechanics relation. Okay, na?
Yes, sir.
So let us try to first define a torque. Torque is nothing but beta, the force which you act on any body so that it will be turning. That is the reason we are calling it as of what? Your turning effect. And two forces are been acting in which direction? Opposite direction part of relation.
Directions. Yes.
Okay, isn't it? So you are exerting the
Yes.
force on that body right now, and the body, because of that two forces, the body is trying to rotate either in the circular motion or else it is making a part of a circle part of relation. That all responsible for your circular motion part of relation. Okay, na? Now,
Yes, sir.
whatever the role is being played by the force in the Newton's laws of motion, the same role is being played by your torque here right now. So the turning effect of force is called as of your, I can write here, the turning effect. The turning effect the turning effect of force is called torque, your torque. Okay, in this one,
Yes, sir.
not only magnitude, direction is also important beta, and how the force is been applied, that is its lines of your actions are also very very important. So the magnitude of the torque is been calculated by the formula. Torque is equals to force into perpendicular distance. Force into your perpendicular distance from axis of rotation, okay.
Yes, sir.
Okay, what force can do beta? In the Newton's laws of motion, we know that force can change force force can change its translational motion, ante kada.
Yes, sir.
So when you apply any force on a body, you can translate the body from one point to another point.
Yes, sir.
In the same way, what torque can do beta? Torque can change the rotation motion.
Yes.
So force can change your translation motion. Torque can change your rotational
Rotation
motion. That is the
motion.
reason torque is being required to increase or decrease the rotational motion condition. So how do you define the torque? Torque is equals to force into your perpendicular distance. So force into your perpendicular distance from the axis of your rotation. So this one is
Rotation.
your perpendicular distance. I'll write this one here. So this one is your perpendicular distance. This is your perpendicular distance. Okay, perpendicular distance from the axis of your rotation part of relation. So mathematically I can represent like this. You see, like say for example, I'm having a rod like this. It inclined ayi undana. There is a rod like this, and this is your origin. Okay, and I am applying a force acting on this one like this. దీన్ని ఇట్లా పైల నుంచి లాగుతున్నాను. Okay, ఇట్లా ఈ రాడ్ కింద ఉంది అనుకో, యాక్చువల్గా ఐఎమ్ స్లోలీ పుల్లింగ్ ఇట్ ఇన్ ది అప్వర్డ్ డైరెక్షన్. దట్ మీన్స్ విత్ ది వర్టికల్ ఐఎమ్ మేకింగ్ అన్ యాంగిల్ ఆఫ్ యువర్ హౌ మచ్ రైట్ నౌ? టీటా. అంతే కదా? This
Yes,
one
sir.
is your theta right now, isn't it? If this is your theta right now, see here, for the given condition, I can resolve this force into two components. One force is in this direction and another force is in this direction. Okay, if this is theta, obviously this one is also theta. In this direction, this will become for me f cos theta. And in this direction, this will become for me f sin
Sin
theta.
theta.
And this is your distance beta. This is your distance from here to here right now. So this one is your r. Now, if I resolve the value of an r, can you tell me what is the value of an r? You can tell me r. This side will become for me how much? This side is your r cos theta, and this will become for me r into your sin theta.
Sin
Ante
theta.
kada?
Yes, sir.
So this one is cos theta, and this side is your sin theta. So torque of your force, this F, about the point O, about your point O. How do you write? You see right now, torque of force F, about O can be calculated by, tell me, torque about point O will be equal to, what is the torque? Tau is equals to force. Okay, I'll write the force about what O. What is the force about your point O? What is the force about your point O which is acting perpendicular? Force into your perpendicular distance right now for this one. So what is the force acting on this body right now in this direction? F into your sin theta. So you need to take the component of the force which is acting perpendicular for this one. It is F into your sin theta. Okay, into your
Yes, sir.
R. Into your R. If you are feeling uncomfortable with this one, you can even write like this. So torque about this one, tau naught is equals to, force is this one na beta. So you write this one as of your force into what I am into what? Perpendicular distance from the axis of rotation. That means E force ki perpendicular emundi. R sin theta.
Okay, r sin theta. Yes.
This one is your R sin theta. You're getting the same thing.
Yes, sir. It's the same.
So
Yes.
tau is equals to F into your sin theta. You already know in the vectors part, A bar cross B bar is how much beta? Mod A mod B into sin theta kada?
Sin theta. Yes, sir.
So like one, the same way I can write here torque also. Torque tau bar is equals to your, how much for your? R bar cross of your F bar, and direction is given by your right hand thumb rule. Direction is
Yes,
given
sir.
by your right hand thumb rule. Curl your fingers from R to your F. The extended thumb will give me the direction. The extended thumb will give me the direction part of
Direction.
relation. Okay, na?
Yes, sir.
So that is about your torque formula. Tau is equals to your what? Tau is equals to your R bar cross F bar. R into sin theta. This R into sin theta is known as of your lever arm. This one is known as what? Lever arm. Or we also called as of your moment arm. Also called as what? Moment arm. అంటే ఈ perpendicular distance మనం ఏమంటున్నాము? Lever arm అంటున్నాం. లేకపోతే we are also we call it of your what? Moment of your
Moment.
or
Yes,
moment
sir.
of your moment arm అని రాస్తున్నాం basically. Okay,
Yes, sir.
isn't it? If force is parallel beta to the axis, then the torque will always be zero. Then torque will always be zero. Why? Because it is passing through the axis kada. Like see, when you're opening and closing of your door beta, you just imagine that if you apply the force at the handle to which the door you are opening, the door is opened very easily kada.
Yes, sir.
Now if you take your hand and move towards the axis on which it is rotating, a joint ఉంటుంది కదా, a joint kada
It
when you
won't
apply
move.
force and open the door and close the door very easily,
No, sir.
it will become very hard kada. And if
Yes, sir.
anything is passing through the axis, then torque applied by that one will be zero. You can't open and close the
Okay.
door very
Yes, sir.
easily, isn't it? That means you need to apply
Yes,
your
sir.
force very long distance from your axis of rotation. Axis
Yes,
of
sir.
rotation ఎంత దూరంలో అప్లై చేయగలిగితే అంత ఈజీగా బాడీ మూవ్ అవుతుంది. If you make your hand or if you make a handle very nearer to the axis of on which the what you call the door is been moving, then closing and opening of the door will become very tough for me,
Yes, sir.
isn't it? So now if I am writing right now for this one, like tell me the forces acting on this one. Let me give you some example. Like say there is some axis like this. This is your fixed. Okay, and this is the handle. మనం సైకిల్ రిపేర్ చేసేటప్పుడు నట్లు ఇట్లో ఓపెన్ చేస్తుంటాం
Yes,
కదా,
sir. Yes, sir.
అలాంటి కండిషన్ అనుకో. నేను దీనిపైన ఇక్కడ ఫోర్స్ అప్లై చేస్తున్నాను. ఐఎమ్ అప్లైయింగ్ ద ఫోర్స్ ఆన్ దిస్ హ్యాండిల్ లైక్ దిస్. Say for example of your F, and I'm making this one as of your angle theta, and this is your distance R part of the relation. ఇక్కడ నుంచి చూడకు ఇది distance right now, isn't it? That means I am indirectly applying the force on this body like this. అంతే కదా. So this is your F and this is your angle theta. If this is theta, this is also theta. You resolve this one theta into components beta. This will become for me F cos theta and this will become for me your F into your sin theta. So how do you write the torque for that one? Torque is equals to force into your perpendicular distance from the axis of your rotation. అంటే దీనికి perpendicular ఏం రాసుకోవచ్చు నేను? F into sin theta రాసుకోవచ్చా? So it is F
Yes, sir.
into sin theta into your R. That means this one is nothing but of your R into your perpendicular force. R into your perpendicular force. ఇట్లా కూడా తీసుకోవచ్చు. ఇది perpendicular force కదా ఈ axis కి,
Yes, sir.
isn't it? So R into your perpendicular force. Now F cos theta వల్ల torque ఎంత నన్న? Torque because of your F cos theta will be equal to 0 because
It is in the axis. So,
force, yeah, force is passing through axis of rotation. Okay, that is the reason torque because of that one will become for me 0 part of relation. Is it clear?
yes, sir.
So let me give you one more example. You tell me the answer for this one. If I give you one more example like this is your rod which is been rotating this body, and here it is your fixed axis. This is దీనిపైన rotate అవుతుంది. I'm applying the forces on this one. So one force I'm applying on this one in this direction. One force I'm applying on this body like this. This is your another force. This is a F1. I'm applying one force acting on this body. This one is say for example F2. This one is for example F3. One force is passing through this one. This is nothing but of your F4. Now torque will be 0 because what force is better? Torque will be 0. Torque is 0 because F3. అంతే కదా.
Yes,
F3
sir.
is passing
Yes,
through
sir.
the axis, that is 0. Torque because of F4 is also 0 because it is passing through the point of axis of rotation.
Yes, sir.
Hinge guard కూడా ఫామ్ అవుతుంది కాబట్టి torque because of your F4 is also equal to 0. Clear? So we can calculate
Yes,
the
sir.
force because of F1. We can calculate the force because of F2 if the gives the angle that we can do in the numericals conditions. Okay na?
Yes, sir.
The next one is torque about center of mass. Like say for example, this is your block, okay, and you are applying the force acting on this one, okay, and what you are doing is here you are applying force somewhere, not exactly from center. Dini center of mass ikkada, okay, from this center of
Yes,
mass
sir.
part of relation, this is your center of mass. Weight of the body is acting in the downward direction mg, okay, and here is your force application, that is nothing but of your F. So when you are applying the force on this body, friction is being acting in the backward direction, that is nothing but of your F, and normal will be shifting in the front direction whenever you apply the force on this one. So normal will try to shift in the upward direction. So this will be the position of your normal. Actually center nunchi undala, but when the body is at rest, this normal will be passing through center. When you are applying the force, this normal slowly will shift in the direction of your force beta. So torque because of your mg will be equal to how much? 0 because it is rotating about the center of mass.
Yes,
And
sir.
torque because of your force will also will be 0 because it is passing through the center.
Yes, sir.
Ona? So torque is only because of what right now? Normal, and this
Normal
one is of
and
your friction. Okay na?
yes, sir.
So I hope you got right rough idea related to this one right now. So force is torque is nothing but what beta? R bar cross of your F bar. Torque is nothing but R bar cross of your F bar part of relation. Now can you give me the direction? Direction is given by how do you give the direction beta? Right hand thumb rule. Right hand thumb
Your right hand.
or cross product,
Yes, sir.
or your cross product. Okay, like if a particle is moving in a circular path like this, okay, and this is your center O, idi distance R, idi force F, okay, so that means this is your R like this, so this is your force F for F, this one is nothing but of your R. Now tell me direction. R bar cross of your F bar, torque will be outward direction or inward direction?
Sir, I didn't get
R
that,
bar
sir.
cross F bar. Take your fingers and keep in the direction of your R bar, beta. First,
Yes,
keep
sir.
all the four fingers in the direction of R bar. Rotate it from R bar to your F bar like this. R bar to your F bar. Thumb is in which direction? Upward direction, kada?
Yes, sir.
Isn't it? Ochinda, చూసుకో try చేయి. Take your right
Yes,
hand.
sir.
Curl the fingers from your R bar to your F bar. Keep all the fingers in the direction of your X axis, that is R bar, and rotate the fingers from R to F.
Yes, sir.
Slowly.
Watching, sir.
The thumb is in which direction? Outward direction. So
Upward
can I say
direction.
that torque is in which direction? Outward.
Outward.
Outward along axis of rotation. Along your axis of rotation. Along your axis of rotation. అంతే కదా, దీనికి ఇది axis of rotation కదా, ఇక్కడే rotate.
Yes, sir.
So torque is also acting along your axis of rotation part of relation. Okay, na?
Yes, sir.
Is it clear?
Yes, sir.
I'll give you one question asked in the CBSE PMT beta once. The question is, if F is the force, if F is the force acting on a particle, acting on a particle having position vector, having your position vector R bar and torque tau bar, tau be the torque of this force about the origin, then first option is R bar dot your tau bar is equals to 0 and F bar dot your tau bar is equals to 0. Second option is R bar dot tau bar is not equal to 0 and F bar dot your tau bar is not equal to 0. Third option is R bar dot your torque tau bar, this is tau beta, tau bar is not equal to 0 and F bar dot your tau bar is equals to 0. Fourth option is R bar dot your tau bar is not equal to 0 and F bar cross your tau bar is equals to 0. So this was a question given for us. CBSE PMT question, medical entrance, all India. If F is the force acting on a particle having a position vector R bar and tau be the force of this torque about this force about the origin, then what is the relation you can write? So what is the torque formula, you tell me first, beta? Tau bar is equals to what? R bar cross F bar,
Yes, sir.
isn't it? That means torque tau is perpendicular to R bar. Torque is perpendicular to R bar.
Yes, sir.
Torque is also perpendicular to F bar.
F bar. Yes, sir.
That means torque is perpendicular, means tau bar dot R bar will become 0 because cos
Yes,
90
sir.
kada.
Yes,
Dot
sir.
product, that will become for me 0. The same way
Yes.
tau bar dot F bar is also equal to 0.
Okay. Yes, sir.
A bar dot B bar form,
Yes, sir.
isn't it?
Both
A
of them are
bar
90
dot
degrees on.
your B bar is equals to AB into cos theta, isn't it? Now see, R bar dot tau bar and F bar dot your tau bar, is it not equal to 0?
It is, sir. Both of them are equal to
Because
0.
all of them are perpendicular. And R bar cross
Yes,
F bar
sir.
ki tau is perpendicular to R, tau is also perpendicular to F. That is the reason
Yes,
tau
sir.
bar dot R bar and tau bar dot F bar will also be equal to 0. So that is the
0.
first
Yes,
option
sir.
is your correct answer for the given condition. Clear?
Yes, sir. Yes, sir.
Okay, fine. See in this one, beta. Can you tell me what is the unit of the torque, beta? Unit of your torque. Tau is equals to what? Tau
Force
is
into
equal to what? Force into distance, na?
distance.
So
Yes.
force is measured in what? Newton.
Yes, sir.
Answer is your Newton and distance is measured in meter.
Meter. Newton.
Newton meter will be the unit for this
Yes.
one.
Yes.
Clear? So the direction is given by what? Right hand thumb rule. If a body rotates in anti-clockwise direction, see in this direction what I got. If the body was rotating in which direction? Circular part. This was moving in which direction, beta?
Sir, anti-clockwise, sir.
This one is anti-clockwise direction,
Yes, sir.
isn't it? So when you are moving in your anti-clockwise direction, then we consider torque to be positive, outward gada.
Yes, sir.
Okay, so I'll write that point here right now. If a body rotates anti-clockwise, tau bar is outside. Tau bar is outside the plane of paper by right hand thumb rule. Plane of your paper. Okay, and if the body is in the clockwise direction, if a body rotates in clockwise direction, then torque tau bar is inside the plane of paper, inside the plane of your paper. Okay, so anti-clockwise direction we take it as positive beta. Anti-clockwise direction, tau is equals to positive. We consider torque to be positive. While clockwise direction, we take the torque to be equal to negative. This is my sign convention. Okay, now? Hello.
Yes, sir.
Isn't it? So anti-clockwise direction, sign convention for torque is what beta? Positive. Clockwise direction, the torque conversion is nothing but equal to what? Negative point of
Negative.
relation. So it's very important. You need to remember in the complete rotational mechanics, this is only sign convention which is going to play the direction of the sign convention of your torque. In which direction will take positive and in direction will be taking the negative point of relation. Now lever arm adugute em chestavu cheppu sir. How do you calculate a lever arm?
Sir?
Or yes beta.
Sir, there's less than 1 minute, sir.
Okay, I'll again rejoin beta.
Yes,
Time
sir.
ఉంది కదా ఒక 10 minutes జాయిన్ చేసుకోండి. Okay.
Yes, sir.
Okay. లివర్ ఆర్మ్ రాయ సార్. లివర్ ఆర్మ్ ఎలా రాస్తాం చెప్పు. వాట్ ఇస్ ద లివర్ ఆర్మ్? ఐ టోల్డ్ యూ ఆర్ కదా. ఆర్ sin theta is known as liver arm. So
Okay,
r
yes,
sin
sir.
theta is tau by f kada.
Yes, sir.
So I can write that one as a your liver arm is equals to what for me?
Tau
Mod
by
of your tau divided by mod of your f. Isn't it? It is
Yes,
r
sir.
bar cross f bar